So now the same area, the same region, which is this region over here, between the line y equal x, y equal 2 minus x, and the x-axis, we are going to rotate it about the vertical line x equal minus 1, which acts as the y-axis. And in Washer's method, what are the rules so far? In Washer's method, if you are rotating about the y-axis or any line parallel to it, x equals a, then it has to be dy, x has to be functions of y, limits are limits of y, and you draw a horizontal line in the region. Whereas in CS, which is the cylindrical shells, anything about the y-axis or parallel to it, which means any line x equals a, like in this case we have x equal minus 1, then it will be dx. The functions have to be functions of x and limits have to be limits of x. That's the idea. So let's start with the Washer's method. In the Washer's method, every single time you are trying to get either it's the discs or washers, here there is a space, this means it's washers, so you need to get the outer radius and the inner radius. Remember, you draw a segment in your region and you imagine that this segment goes from the bottom up. This segment, it has to be perpendicular to the line of revolution. All right, so if it's vertical, it has to be horizontal. This is in Washer's method all the time. Then you start, you need outer radius and inner radius. Always remember, your radius starts from the line of revolution to the outside of that segment, which in this case is right minus left. But the most important thing that students forget is to change their functions into functions of x. So x equals 2 minus y, and here x equals y. So it becomes the outer radius is 2 minus y minus minus 1. So 2 minus y minus minus 1. So it's 2 plus 1, 3 minus y. And the inner radius is from here to the inside. How long is this? This is y minus minus 1, which is y plus 1. And then what will the volume using Washer's method be? It will be pi integral. The y is from 0 to 1. Limits of y, of course, from 0 to 1. Then you have the outer radius, which was 3 minus y squared, minus the inner radius, which is y plus 1 squared dy. You expand, you subtract properly, and then you integrate one by one. Whereas if you're doing cylindrical shells, and I will do it in blue, in cylindrical shells, you have to draw in the region a line parallel to the line of revolution. If you notice here, what we will suffer from is the same thing that we suffered before when we did Washer's method in the previous problem when we were rotating about the x-axis. See here, if you notice, from 0 to 1, the vertical lines look different than they look from 1 to 2. So in the previous problem, cylindrical shells made things easier. Here, washers made things easier. So to notice that really a wise decision can save you a lot. So over here, if you draw vertical, you notice that what do you have to do in cylindrical shells here? If you are dealing with this from 0 to 1, it's something, and from 1 to 2, it's something else. Let's try to draw the cylinder here. The cylinder here will have what height, and you use what functions? You use y equals a function of x. Always draw this table when you are trying to decide to know which one is easier and to know what you are handling and how you should manage your functions, because you can easily mistake between using functions of y or functions of x. So here what do you have? The height is x minus 0. So for the first section, from 0 to 1, you do 2 pi integral from x equals 0 to x equals 1. What is the height and the radius? The height is x minus 0, so x, and the radius is from the line of revolution to here. The line of revolution to here is x minus minus 1, so x plus 1 dx. This is the first one, plus 2 pi. Now the other section, which is running from 1 to 2, what is the height? The height is 2 minus x minus 0, so 2 minus x, and the radius is again x minus minus 1, so x plus 1 dx. Which one is easier, doing one integral or two? Of course, one integral is easier than those, but they are doable in both ways. So this is the idea of the difference between Washer's method and cylindrical shells method, whether you are rotating x-axis or y-axis. So to make for you the final table that you should always think of, first thing you look at, what are you rotating? If you are rotating x-axis or any line that looks like y equals b. So the x-axis, always remember y equals 0. Any line that is parallel to it or looks like it, so y equals b, is treated the same way. How is it treated the washer's way? Always remember the x-axis is horizontal. When we use washers, it has to be a vertical cut. And then washer's method, you need to get outer radius and inner radius. Always your radii start from the center of the rotation on the line of rotation. But what should your functions look like? Washer's method, x are dx. Yani functions should be functions of x. Limits should be limits of x. And the line you draw is a vertical line. In cylindrical shells, it's the other way around. You need h and r, the height of the cylinder and the radius of the cylinder. The height will be parallel to the line of revolution. All right, this is your height. And then it's parallel, so it's horizontal here. And then it's dy, so functions are functions of y, and y equals c to d are your limits of integration. Whereas if you are rotating about the y-axis or any line parallel to the y-axis which looks like x equals a, then washer's method, or the disks method of course, uses dy, functions are functions of y, and limits are limits of y. Whereas in cylindrical shells, and how do you draw your washer's method segment part? The y-axis is vertical, so you draw a horizontal line in your section to be able to know from the line of revolution to the outside, from the line of revolution to the inside. In cylindrical shells, it will be dx. This means y has to be a function of x, and this means that limits have to be limits of x. And how do you draw? You draw parallel to the y-axis, so you draw a vertical line in your section. This will be your height, and then the radius will be either x or y minus or plus the line that you have. If it's not the y-axis, which is x equals 0, you will have to subtract a according to which one is on the right, which one is on the left. What are the formulas? The formulas for washer's method is v equals pi integral outer radius squared minus inner radius squared, and you integrate either dx if you are about the x-axis, or if you're about the y-axis or something parallel, ro squared minus ri squared dy, and those will be limits of y. Always remember, those will be here functions of x, those will be here functions of y. Whereas in cylindrical shells, the volume with respect to the x-axis will be equal to 2 pi integral from y equals c to y equals d, r which is a function of y, h which is a function of y dy. And if it's with respect to the y-axis, so you'd have all the information written also, it's 2 pi, and then you do the other way around, so it's x equals a to x equals b. R will be a function of x, the height will be a function of x, and you will integrate with respect to x. Believe me, if you memorize this table and you put it in front of you while you are solving in an exam, you should be free from mistakes. Many problems in those techniques happen because students either keep the wrong functions or take the wrong limits. You have to put this table in front of you. How do you work with this table? What do you decide first? First, you decide the axis, x or parallel to it, or y or parallel to it. Once you decide whether it's the x-axis or the y-axis, you put in front of you the two methods, washers and cylindrical shells. To make your life easier, first, if the functions cannot be changed, then the decision is made already. Because if the functions cannot be changed and you're rotating about the x-axis, if you have y as a function of x, you have to use washers. If you have x as a function of y, you have to use cylindrical shells. Now, if you can interchange and change from y equal f of x to x equals g of y, if you can do this and change, then the decision, how do you decide? You draw a vertical line if you are about the x-axis and a horizontal line if you are using cylindrical shells, and you decide which one makes the section you are working with easier. If a vertical line makes it easier, you use washers. If a horizontal line makes it easier, you use cylindrical shells. Here, you do exactly the same. Washers method and cylindrical shells. If you are rotating about the y-axis, washers method says dy, this says dx. So here it has to be x equals a function of y. Here y has to be a function of x. If you cannot change, you stick to the forced method. You cannot choose. But if you can change between f of y and f of x, you can rewrite them. Then again, for washers method, you draw a horizontal line. For cylindrical shells method, you draw a vertical line, and you see which one makes things easier, just as I did in the two previous examples that I had. Good luck.